Hello, everybody, and welcome to today's lecture where we're going on a ride to uncover one of the coolest things about our brains action potentials. Yep, those saps of electricity that make our neurons dance and communicate like rock stars. So, buckle up and get ready to explore the world of action potentials. So, in today's lecture, in first place, we're going to be giving a definition of what an action potential is. And then we're going to be going through all the process of an action potential with the goal to find out how neurons communicate. So, let's get started. Let's begin by defining what exactly an action potential is. In essence, an action potential is a brief electrical impulse that travels down the length of a neuron, enabling it to transmit information over long distances. It's good to say that this process is absolutely vital for everything we do, from thinking and moving to feeling and sensing the world around us. So, how does it all start? For this explanation, I would like for everybody to think of a neuron like a battery waiting to send a message. At rest, it's just chilling, maintaining a balance of positive and negative ions inside and outside the cell. This balance is super important because it sets the stage for the neuron to fire off its message. Now, when a neuron gets stimulated, maybe by something you see, hear, or feel, it's like flipping a switch on the battery. Suddenly, there's a change in the electrical charge across the neuron's membrane, and this is called depolarization, which is this process that we can see here, when the neuron goes from being at a voltage of minus 70 millivolts all the way up to plus 40. This happens when positive ions rush inside while negative ions head out, creating a wave of electrical activity, like this one that we can see here. This surge of electricity travels down the length of the neuron like a ripple in a pond. This is called the action potential. Along the way, it triggers more channels to open, allowing even more positive ions to flood in and keep the message going strong. But here's the cool part. As the action potential reaches its peak, which is this one that we can see here at plus 40 millivolts, the neuron needs to get ready for the next message. So it undergoes repolarization, which is this process that we can see over here. This process happens when it pumps out the positive ions that rushed in during depolarization, bringing the electrical charge back to its rating state, which is at minus 70 millivolts. However, sometimes the neuron overshoots its resting state and becomes even more negative than usual. This phase is called hyperpolarization. It's like the neuron is extra cautious, making sure it's really ready before it can fire off another message. Once the action potential reaches the end of a neuron, it's time for the message to jump to the next neuron. This is where the synaptic transmission comes into play. The action potential triggers the release of neurotransmitters from tiny sacs at the end of the neuron, called synaptic vesicles. These neurotransmitters cross the synapse, the gap between neurons, and bind to receptors on the receiving neuron, continuing the message. So, with all of that explained, I hope that you enjoyed today's lecture, and let's wrap it up here. Thank you for being part of this journey today, and now get ready to answer 5 multiple choice questions about this topic. Once again, thank you.